Hey guys, Joe Pye here at Advanced Innovations. Welcome back to the shop. The next pieces that I will address will be these guys right here. These are the cylinders, and they're a little different than the print calls out, and the print doesn't call out much. Print gives you a couple of tapped hole locations, a couple of port locations, bore diameters, etc., etc. But when it comes time to putting the oblique holes in that allow the pressure to get from the steam chest into the cylinder on both ends, it basically gives you nothing to go from, and that is going to be an issue for a lot of people unless you have CAD capabilities or you're just plain lucky. First thing I'm going to do, and I'm not going to show it because it's going to be boring, I'm just going to file off these flash lines right here, and that's going to be about the only filing required for this component. I am going to run a file across the outside to make sure that there's no flare to the end of the part, which is not uncommon for stuff like this. And just clean it up, basically give me something to hold on to. Going to press this face against the sander, this face against the sander, and this one as well. And it gives me an opportunity to measure the ports on the bottom and figure out exactly where everything is. I will CAD this out right here, and I hope the guys at Stuart don't mind me showing this, but there's no angles given here. There's basically no locations. The location of this, aside from the 1/4 inch diameter, is not given. There's a depth given and there's a diameter given, but it doesn't tell you planar where it's located. So based on where this is located and how deep these are, these angles could change, and where you want this to break through, you don't want it to break through in the cylinder, you want it to break through in that little pocket. So we'll figure that all out. And as far as the other detail here, this 1/8 dimension, I don't know if it's the same on your print as it is on mine, but I believe that this 1/8 dimension should be called out across these two lines here and not to the third line out. That would really pull this thing off center big time, and that would be a problem when the valve functions inside the steam chest. So let me get some sander work done, some file work done. We'll go sit down on the CAD and I'll show you the model I created, and I'll give you the numbers on how to find these ports if you're in fact building this model as well. Stick around. Filing and blasting is complete. Flash lines are gone, ugly's gone. Surfaces are sanded flat to an inspectable point, but certainly not finished geometry. Now ideally, I want these ports in the middle of this base because the slide is going to be constrained within the steam cabinet or the steam chest that goes to the side. That may lead to a little irregularity on the end webs, but this is more important, and this is hidden at assembly. Although it shouldn't be. That looks pretty cool. I like the way that looks back to back. But the difference would be minimal. There's about 3/4 of a millimeter difference off center. You can see how it looks. And as far as the depth and placement of those are concerned, well, I guess that's up to you. So long as the steam gets in, steam gets out. I'm going to pop over to the model, see how this compares to the model from the print, and figure out exactly where to start. Let's go inside. Okay, what we have here is a very accurate rendition of the model that they want you to produce. 3 ports on the bottom, and the rod through the center is just strictly a construction rod that will be a hole in a port. It'll be one-sided, so if it doesn't look like something on your print, it's probably because it's not. The little guy on the end here is the 1/4 inch diameter scallop 093 deep that they ask you to put. And since there's no dimensions on it except for the diameter and the depth, I have it constructed so that the center of this feature right here is on the diameter of the through bore. So unless you walk the cutter in from the center, these will be a little bit of a scallop right here on either end. It really probably doesn't matter. The hole itself was basically put wherever I wanted it. The slots on the side were reconstructed based on the depth of the slots in the casting. And if we query the depth of these things, we can see that I will end up making these 180 deep. That is pretty straightforward. These are 093, and the one in the middle is 125. So that's 3/32 imperial and 1/8 inch imperial. It's about 2¼ millimeters and about 3 millimeters in the center. Let's take a look at the oblique hole because that's going to be the one that's going to give everybody grief. This is how I'm going to approach that hole. And if you watch my other video on the steam engine series, you know I'm going to use a tooling ball and a sleeve to locate this oblique port. And there's the port. The port will go through from the 1/4 inch scallop on the end to the first intake port on the bottom where the steam chest is going to be. It's going to intersect only the steam chest and only the scallop and not interfere with the bore, the top surface, or the inner wall. The way the tooling ball is going to be set up, the tooling ball is going to be set up directly on the axis of that hole. If you were to project that all the way out, let me turn on the axis of the part and take the axis of the main bore and project that all the way out, it falls dead center in the ball. So once the part is set up, it's going to be a vise in a vise. I'll just simply indicate the tooling ball and I'll know that I'm perfectly on center with the port that I need to put in there. And you may have seen me do this in the past, but I'm going to stick a piece of wood in this port because this is going to be a relatively blind operation. And I'm going to drill down until I feel that piece of wood start to jiggle, and I'm going to know that I'm right there. The last thing I want to do is violate this web in between the intake and the exhaust ports. I will give the dimensions out at the somewhere along the line here. Let's see if I can find out what that is right now. That works out to be 57.635 degrees. Now 0.635 is not 0.63 minutes. It's 0.635 of 60 minutes. So that's probably about 36 minutes-ish. I can tweak that however I want. I will probably tweak it just a little bit more so it's an even number. And if I do that, I will absolutely let you know. But that's the setup that I will be using right there. Kicked off, vise into vise, tooling ball, comes straight down through the pocket, which will be done first, and away you go. Looks simple on the screen. It would really be nice if these dimensions were on the print. I feel somewhat bad for the people that don't have CAD capabilities and proud of the people that have done this without CAD capabilities. So kudos to you. Good job. Let's set this thing up in the mill, bring it to size, get everything ready to drill, and off we go. I'll make sure that I cover that as well and explain it as needed. If you have any questions about why I'm doing something that I'm doing that I don't explain very well, well, feel free to put it in the comment line and I'll do my very best to answer your question. Let's go back to a solid body here. Any kind of luck, when I'm done on the machine, the part that I'm going to make is going to look like this. But I can promise you that my ports on the bottom are not going to have square ends. They're going to have round ends. And if the slot dimension is called out as, I think these are 281 long, don't go 281 center to center, because then the radius of the cutter is going to exceed the dimension on the print, and technically that port's going to be a no bueno. So make sure that the center to center distance on whatever cutter diameter you use, you incorporate at least one diameter off of the overall length, and that'll be the center to center dimension overall. Let's do it. Well, before I dive into the mill and start truing up these surfaces, the first thing I want to do is just establish something I can grab onto. And I think that review of the print is probably a pretty good idea before you start throwing chips. Take a good look at the features on the print, on the finished configuration, and figure out what you can work from, what you need to work from, and what you can cheat and sacrifice based on your own preferences. I like visually symmetrical. That is very important to me. And dimensionally correct is right up there with visually symmetrical, so let's just put that on the list as well. Looking at the back, the ports are pretty close to right where they want to be on this one. On this one, whoa, whoa, whoa. This is a little off center. This is a heavy side. You can see that. And I would say that's a heavy side as well. This one is considerably better, but, and here's the but, here's the valves. If the valves can make up for any discrepancy in the alignment of the ports on the bottom, well then so be it. It's not going to be a big deal. And if worse comes to worse, and the valve just doesn't accommodate what you need, well, find a machine shop and have them make you another valve. Oh, wait a minute. We are in a machine shop, so we'll make our own valves. That is not a big deal. In order to start a part like this, I've got them sanded and blasted to the point where there's no more flash lines. These surfaces are relatively flat, not necessarily square, parallel, or true to anything. So, ta-da, Mr. V-Block is going to step in here and sit right there on the barrel inside everything. And I am going to true up one surface. And from that one surface, I will create my kingdom. I will dust one surface, hold it on that surface, this surface, whatever, and I will continue to work from the fact that I know that I now have a flat surface that I can trust. So once this one's flat, I can flip it against the stationary jaw, dust this off, and then I have two surfaces that I can work from to establish the third, and then we'll just true everything up center-wise, bringing in the ribs, trying to maintain the ports on the side in the middle, the valve slots or the steam ports on the bottom in the middle, etc., etc. Some of this might be fast forward because I just described exactly what I'm going to do. This is not the print. This OD right here is not 1 3/8 like they've called out on the print. It's about a millimeter undersize, and that is not by my hand. That is just the way it came. So no big deal. As long as I can maintain the center of the bore to the bottom, doesn't really matter what the tangent diameter is. It ends up being strictly cosmetic. Let's pop it in the mill, make a couple of crazy tool paths with an end mill, and see what we can come up with. Okay, now if all went well, I should have 2 square sides and 3 flat surfaces. But in the interest of actually going back and maintaining one to the other, instead of going boom, 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 and squaring up surfaces, which I don't like to do, I'm now going to hold it here, indicated parallel, and take another dust cut off the bottom just to be sure. Then we'll figure out where everything is size-wise, what comes off of where and when. Let's do it. All went well, everything is true to the world. Let's take it out, do some dimensional checks on it, mark up the surfaces, and center everything up as required. Now that I have some reliable surfaces that I can work from, I'm going to check different geometries, and I'm going to check the height of the ends here, and if I have to, I will adjust the way this thing sits. Let's see what we got. 471 on one end. 477 on the other. 6 thousandths difference. So let's call this 0. and +6. Did the same thing for the other part and came up with 0 and +10. No big deal. I am not shook up by this because I registered off the inside feature, but now I'm just going on the outside since I have surfaces that I can trust. So how do we straighten that out? Well, let me show you. Now, you don't have to do this because I'm sure this model will work just fine if you don't, but it's not your model, it's my model, so this is how I'm going to do it. Let's reverse it this way. I've got the plus side over here. I'm going to put this in the mill, in the vise, and I'm going to lift it, and I'm going to indicate it back and forth until my indicator reads 0 and +6. Then I'll know that the heights of the ends are spot on. After that, I will go back through the process that established the ends, flip, flip, and everything should be copacetic. So that is the next operation. If you see this thing sitting in the machine, I will do exactly what I just said I'm going to do, but I may not be talking while I'm doing it. I'll line it up on the bench here on this little plate, 0, and then when I go to the machine, I will put the indicol on the spindle and I will offset it as such so the cut is biased 0 and remove 6 here. And then I'll pop it out and show you what I got. 466. 466, there you go. I like it. It is not squared to the ends, so it will go back in for the flip-flop that we saw before. But I got to put the other one in, do the 10. But that's a good way to do it. 2 vices, problem solved. Let's move on. Now, although you have already seen this particular operation, I came up with a different setup for the second go-round. The bar is supported on either end by a couple of helper blocks. And the back side, since the back side was tapered, the only way to register that is on a cylindrical surface, so that's the way we did it. This has worked out quite well. Got to move on to the bottom and establish the overall height based on the center of that bore right there. Well, not that bore, the bore that will ultimately go in there. Well, I may have to voice over this because there is a vibrating steamroller outside of my shop repaving the racetrack that they call US 183 here in Liberty Hill. And these are the parts. They are officially correct on the width. Centered up as best I could, visually and dimensionally. Next thing is to figure out where the center of this arc is in relationship to this flat. Now that doesn't mean, looking at this part, that the part is not clocked this way or this way when it comes to the flat, to the arc, because it could be off center and flat, and you know, it's just not going to end well. So I come up with a way. I'm going to check these dimensionally, actually physically check them, give myself a reference point, and this is how I approached it, because I want that angle to be exactly the same on either side when that flat is formed. Taking a known square vertical surface and press the block up against it, I'm going to check the gap right down here in the corner with a variety of pins. And when I get the pin that can sneak under there nicely, flip the part over, check the other side. And if one side fits and one side doesn't fit, well, if you have it within your means, grab a couple of other sizes and find out exactly what you're up against. These parts are actually surprisingly consistent. Get a 145 pin under one side, 138 under the other side. That's only 3.5 thousandths difference off center, which is pretty good. but not good enough. All right, this one is 139, 146. That is also 3.5 thousandths off center. Also very consistent to the first one. Now, when I set these up in the machine, knowing that this is the wide side from a vertical, I'm just going to bump it just a little bit this way to close up that 145 and open up this 138. That's the gap on top. So basically, this is what I'll be doing. Shifting it to one side to accommodate this number. It's not going to be much, only going to be 1,000th or so on the low side. But for what I'm doing, that's how I want to do it. And then we'll just decide how much to take off here to get it to the center of this arc. And it is okay to measure across the arc, because on a tangent like this that runs out to a downhill, let's look at it this way. A tangent surface that runs off on a downhill runs off beyond center. So there is a very small chord of actual diameter there, so it is safe to measure across here to figure out what the arc is. Hope that made sense. And once these were machined on the mill, I just took them over and ran them on some 220 emery, and boy, that came out nice. Okay, let's set them up, mill these guys, and start figuring out what we're going to do with these pockets. As promised in the inspection room, I am bumping this side of the part just a couple thou higher than the other side. That will move the angles more in line with what I had hoped to see. This is about a 2,000ths difference from side to side. And I believe that will at least move us in the right direction, if not spot on. I have to take 22,000ths off this surface. That's about just a little over 0.5 millimeter. And because of the angle of the surface, I'm going to wait till the cutter cleans up right dead center before I start calculating the 22,000ths that needs to be removed. Let's do it. When that area starts to clean up, about 50%, that's when I'll zero my table. Let's do it. And for anybody wondering why I'm not using a fly cutter on this, well, I don't want these chips all over the place, and I don't feel like breathing cast iron dust. So I can control the cut, control the burrs pretty good with this end mill. This is a 5/16 end mill. It's about 8 millimeters, and it's a 4-flute titanium aluminum coated cutter. A couple more thou to come off of here, and then we'll figure out what to do with those ports. Knowing that this is a very true surface at this point, this is a great time to put the bolt holes, and any port work that you're going to do it now. Next step in the process is to find the very center point of this plateau on the end of the part. This is for the 4 steam chest mounting holes, not for the ports. The ports I'm going to have to pick up. I will pick up the center port and zero out the table again for the ports. But for right now, I want to find the dead center of this guy right here. These sides are tapered, and unless you're going to wing it and hit this by eye, which you probably could with some degree of competency, using a pointed wiggler or some other pointed device, but I'm going to try something different today, just thinking that's a good idea and the way I want to go. I know the height from the top of the part to the vise, so I'm going to take that height and I'm going to double it. That's going to be the maximum diameter, working diameter, that I can use for the pins that I'm going to use on either side of that. I'm going to go a little bit smaller so I don't register on a chamfered edge. And just so the indicator doesn't push the pins out of the way, I'm going to back it up with some blocks. Now just simply sweep the insides of the pins. Zero on that side. Zero on that side. Now, I will admit that I did set this up off camera. I am not that lucky. Once in a while, I get that lucky, and I actually have to hit the indicator and make sure that everything is not stuck. But that's what you're looking for. If you're going to go down over a pin, you watch the indicator in the vertical. I'm finding the maximum diameter of that pin right there. Then I'm going to rotate it to look for the high spot. Okay, so it's a coordination of two planes. Right now I'm sweeping, and right now I'm up and down. So make sure if you're going to do a pin, do it that way. You absolutely must go up and down looking for the highest point you can get, and then go back and forth and look for the lowest point you can get. At that point, it is safe to zero out the X digital and trust that you're in the middle of this part. I'm going to do the exact same thing for the ends, but I'm not using pins because I have a vertical surface to work from. That'll be my Y center. What just happened? Come on back. There we go. Now, like you've heard me say in the past, if you're going to indicate something, if you don't have a center line function on a digital or whatever, keep the indicator needle above the part and watch for the sweep. Set your part up just relatively close with the indicator above the part. When it looks like the ball is as far on this side away or that side away, very symmetrical to the view, to the eye, then lower it down and make contact and see what happens. Now, I have not set this up off camera, but I'm going to see how close I can get, just because. Call it right there. Let's see what we got. Zero. Moment of truth. 1,000. By eye. What? Yep. And you have to take my word for it. I swear to God, swear on my children's eyes. That's the best way I can say it. I did not set that up off camera. Damn, I got lucky on that one. 5/10,000ths of an inch off center by eye. I better go get my glasses checked, huh? Good time to zero out the Y. I would say there's no reason to mess with anything at this point, but I can't not leave well enough alone. There we go. Minus 5/10. Minus 5/10. Okay, that is my XY0 for the bolt pattern. Bolt pattern is 782 across all four holes, 391, just shy of 10 millimeters off center in every direction. Let's do it. All right, although it is not plain to see by the way this is positioned right now, if all went well, those holes popped out in these voids down here. I had no idea that was the plan, but that looks like exactly what they had intended. So there you go. There's a really strong reason for keeping the outside symmetrical as much as possible. See if I got lucky. I'm going to tap these before I take it out, and I'll be right back. Without the part having been moved from the tapping operation, I've got a pin in the drill chuck, and I'm going to map the existing casting port locations by just filtering or finding where the pin fits in the 3 slots. When I find the center of the center slot, I will naturally zero out my digital. I'm going to work my way back and forth looking at how the pin mates on the end slots and find the locations of those as well. I may adjust the Y center so that the move off center for each of the end ports is symmetrical. Once I have the Y center this way, I will track the X center the same way. Recording my values as I find the ends of the slots, split the difference, and come back for the center. At this point, it's just a matter of putting the slot in there, or putting the port in there that you feel comfortable with. Now, I may take some design liberties here, and hopefully it works, and when the engine starts up, when I'm done building this thing, I'll share with you what I did. But let's just say that the pin that's in the chuck right now, this pin here, is oversized from what's called out on the print. Therefore, when I find the locations of the ends, I'm going to make sure that it's the tangent that's in line with the existing casting material. So when I make this cut, it may just take from the outside and not the inside, but I'm perfectly okay with that. It's been thoroughly analyzed. Let's put some cutters in here, make some chips. All the slots are complete at this time. The overall length of each slot is identical. The center-to-center distance of the center slot is a little bit smaller than the center-to-center distance of the end slots because of the cutter size itself. So I think it is safe to remove this part from the vise right now. Take it over to the bench. Take a look. Model's shaping up nicely. The next operations will be the through bore, the scallop, and the oblique holes, and 10 tapped holes on the ends. You can see how the steam chest mounting holes broke through. I'll take that as a win. I don't know if they were supposed to break through or not, but hey, it's always nice to be able to push a tap all the way through a hole, so that's what I went for. These guys here, the center port is a little bit deeper. Actually, the center port's about 2.5 millimeters deeper than the 2 side ports. And that is so that the connecting hole here doesn't really encounter half a hole. It should fall right straight into that void if all goes well. The depth that I had calculated on the end ports is right about where I guess the manufacturer had thought it would be, because there is a little remnant casting on the bottom. And that's okay. So long as it's not loose, it's not a problem. Okay, let's figure out how we're going to hold this thing next for the operations to come and go from there. Do it.